Awesome. Okay, so we have Junyang here, one of the authors of the Qwen2 LLM paper. We saw amazing results from Qwen2. I think compared to even Llama 3 on some of the popular benchmarks we are using, they outperform Llama 3, which is really impressive. And I think I and the whole community was fairly surprised by this. So I decided to invite the guys. And thanks, Junyang, for coming. I think you can briefly introduce yourself, and then we can kick it off. Thanks for coming again.
Yeah, thanks.
Hey guys, I want to give a huge shout out to Hyperstack folks who have generously sponsored my compute over the past month or so. Basically, I got 16 H100s, which is 2 8 GPU nodes, and the performance has been amazing. Basically 2x the speed up compared to my A100 nodes. So I want to quickly show you how you can get started yourself. It takes basically 3 steps only. You go to the environments here, you create a new environment, you give it a name, you pick between Canada and Norway. That's the first step. The second step, you go to SSH keys here, you create a new pair, you pick the environment you just created, you give it a name, you paste your public SSH key. That's it. And finally, go to virtual machines, deploy new machine, give it a name again, select the environment. Let's select Canada here because they have more compute there. Then you select the hardware you want, like for example H100s. You select the images, you select the SSH key you just created, and hit deploy. That's it. Literally a couple of minutes to get started. It was really easy for me to just basically create these 2 nodes I just mentioned and get started running LLM trainings. So the documentation is super cool. I could actually solve all of my problems just by looking at their docs. They additionally have a Slack channel where they were super helpful, so I can't recommend them enough, honestly. The thing they kind of focus on is basically, because a lot of these GPU providers focus on big enterprises, so oftentimes you can't get on-demand H100s, whereas NextGen focuses particularly on that. You can get top-of-the-line hardware on demand, even if you're an individual or like a smaller team or whatnot. They also focus on bigger companies, but that's kind of their edge here. So without further ado, guys, let's go back to the talk. I do suggest you check them out, and let's continue.
Alex, for the introduction, and very happy to be here with you guys to introduce Qwen2. I think this is the first time for me to introduce Qwen2. I usually present Qwen1 and Qwen 1.5 to a lot of guys, but this is the first time for Qwen2. And I use the title called towards a generalist model because we not only build large language model, we also have large vision language model and large audio text model, and you can check it in our GitHub and you can find it. Yeah, I am a part of the Qwen team. I actually I pay most of my attention to leading the LLM team, and I also spend some time in doing the vision language model. And something about me, I am actually a guy who previously learning generative AI, which is I just do something very simple, natural language generation or translation and summarization in 2018. But very luckily, I'm doing these things, so I get in touch with Pretraining language model, and I'm very lucky to have a chance to follow GPT-3 to build something large models in 2020 and 2021. But then we get back to think about like unified multi-model learning, because we would like to build things like an AI system which is compatible with multiple modalities and multiple tasks. And then ChatGPT just came to us, and we just found that, wow, this is the brain that we are eager for a long time, because we have an AI system, but we do not have a smart brain, and maybe a large language model is the answer. But in 2023, we have some resources, and we try to build the Qwen series large language model. And for a year now, we have Qwen2. And this time, I will introduce some details about Qwen2 to you. And if you have any questions, just shoot me.
I'm curious, when was Qwen started as a startup? That's kind of the first question. The second one, you said you were training 1 trillion mixture of experts back in 2020. Which company? Where was that? That's impressive.
I have been Alibaba Group for my whole career. I am also in the same team. But previously we were not called Qwen team. We were just a bunch of guys, the same guys together. Now is the Qwen team. Yeah, in 2021. At that time, we were very lucky to have some chance to build large language model. I don't know if you are familiar with the time for GPT-3, because not many people are training large language model. We are actually, essentially, it is a multi-model model, but we are doing something like we first train a 10 billion dense model, and it is very, very large at that time because we do not have so many things for us to support it, to train it stably. We even need to use FP16 to train a model. You know, today people are using BF16 to train the model. It is very stable, but at that time it is very unstable. And we are doing MOE model at that time. You remember like G-Shard and switch transformers? We are actually following these things. So we are building very, very large MOE model, but actually it is very, very sparse. And at that time, we do not have data scaling, so actually we do not use many resources for it. I remember that I used like 500 GPUs, just V100, and trained for like a week. So you can generally build a 1 trillion MOE model. Yeah, not that difficult today, but difficult at that time. Yeah.
Super impressive. And then Qwen is like almost like a startup inside of Alibaba. You're just shipping and focusing only on LLMs. That's how I understood pretty much. Or you said it's multimodal. Everything kind of falls under the Qwen team.
Maybe I just make it look like a startup, but we are actually a team. Under the whole Alibaba group, and we have connection with Alibaba Cloud. So we have some GPU support for us to do these things. But I'm very lucky because my company supports my open source. So we have open source, and we can use our brand, and we can use our blog site. So this makes us look like a startup, but actually we are not. Yeah.
Got it. Makes sense. Thanks.
Yeah. Sure. Let me move on to the Qwen2. And this time for the Qwen2, we have 5 sizes. If you're familiar with Qwen 1.5, we have nearly 9 sizes. There are quite a lot. We have small models and we have large models. For most of the time, we focus on the Qwen2, Qwen 7 billion model, because there are a lot of people using 7 billion model. And after we have done successful practice in 7 billion model, we just scale it up to larger models. And previously we have Qwen 72B and Qwen 1.5 72B. There are a lot of users using it because it is not easy for you to find a 70 billion model in the community, especially in the Llama 2 era, and Llama 2 70B is the only one. So there are a lot of people using it. But due to our design and the concerns of use the GPU resources, so for the medium sizes, previously we had 14 billion and 32 billion, but we tried to make it a MOE model. So we call it 57 billion A 14 billion, which means that you have in total 57 billion parameters, but only activates 14 billion. It is an MOE model. You can treat it as something competitive to Mixtro for the sizes. Yeah, there's something like that. But we also have small models because we have done a lot of experiments in small models, and we suddenly found that there are a lot of people that are very interested in small models. Even some people are using it in the cell phones. So we just released it. It is very easy for us for the 0.5 or 1.5 billion parameter models. And you can find that our models for the parameters and non-embedding parameters. For this time, we all use GQA, so you can inference it with fast speed. And for the context length, we have found that for small models, it's not easy for you to scale up to very long context. So you can find that we're just limited to 32,000 tokens. But for 7 billion and especially 72 billion, you can extend it to like 128,000 tokens. Yeah, it is actually quite long. You can check the model card. We just tell you how to use VLM with static yarn to extend it to 128,000 tokens. It is relatively stable. And for this time, we have a lot of language support. Previously, it is also a multilingual model. I think for most of the large language models today, it is essentially multilingual because you are using the data from the whole world to train the model. But this time we have paid special attention to some languages because we have collected some data, and there are a lot of data, from Western Europe and Eastern Europe and also Eastern Asia. But this time we do not pay attention to the African languages. Maybe in the later time we can add it to it. And we have pay attention to 27 languages besides Chinese and English. Chinese and English are still the most the largest part of our training data. Yeah.
Junyang, and from my side, do you hear me?
Yeah, sure.
Can you go back to the previous slide? Just a question on the smaller models. Like, I'm curious, have you noticed any interesting edge application? You mentioned some mobile apps, people using LLMs in mobile applications. Do you have any interesting use case you've noticed people using Qwen for this range from 0.5 to like 7 billion range?
You mean using the small model smaller than 7 billion? Yeah.
Yeah. For whatever type of either microcontroller or smartphone or some type of edge applications.
I don't think they have used so complex things. I don't think the model has the capability to do very complex stuff. But for these people to train to put it on cell phones, I have touched. They are still mostly doing some simple tasks like summarization, translation, and simple QA and chatting. But for the controlling things, they cannot do very complex stuff. Today, even for agents, you need to use GPT-4. I have another project called OpenDevon. Yeah, they would like the model to automatically to write code and execute code or things like that, to playing as a coding assistant agent, but it is very hard. You have to use very large models. So for smaller models to really control the mobile phones, I think it is still a bit difficult. But for 7 billion model, it is I think it is possible. I have some customers, they are actually using it for some simple controlling in the laptop, and their cell phone is a bit hard because it is too large. But for the laptop, doing some simple controlling, it is okay. But most of the time, they are doing traditional tasks like summarization and like table QA or some search or not search, but translation, summarization, and simple QA and chatting. Yeah, these things are most of the users.
Thanks for letting me know. One question from the chat: what are tokenizer considerations to optimize for both Chinese and English? Any insights on tokenizer? If you're going to cover that a bit later, then you can just keep the question and answer it a bit later.
Yeah, I can. I will cover this part, but I can share it to you directly. This thing is what we have been concerned in last year, like April. Yeah, at that time we are considering about the tokenizer. We have compared like Llama tokenizer, and there are some other tokenizers. From other models. At that time, most of the open source models training from scratch are from China, so we have some comparison with ChatGRM, Bytron, or anything else. And we have found that our design of tokenizer based on we are using tick token because we believe in OpenAI. And for the CR100K, I don't know if you know about it. Yeah, the GPT-4 tokenizer, it is a good start for things, but we have extended for some multilingual support. Most of the support are about Chinese at that time, because at that time we don't really expect to really build a multilingual model at that time. So we just do most of the things for Chinese, but we also have done some simple things for other languages. Yeah. So this is a tokenizer. It is actually simple, but I think today people are actually following this trend. They are also using tick token, and they are also using the BP tokenizer. Even for Llama, they are changing from the sentence piece tokenizer to the BP tokenizer.
Got it. Just
Yeah, I will.
clarify. Basically, you're using pre-trained tokenizer from OpenAI. You didn't train your own from scratch for the subset.
Yeah, I don't think it is necessary to really train a tokenizer from scratch. We just add the tokenizer to extend the vocabulary. You can find our vocabulary size is about 150,000 tokens. Yeah, for the original BP tokenizer, it is around I remember it's 100,000. Yeah, just 50,000. Yeah, 50,000 more. We have trained something from scratch for the tokenizer as well, even using like a sentence piece. But for comparison, and finally, we decided to use this. I think this one is better. Besides the large language model, and for the large language model part, we also have pay attention to the code language model. And previously we have Qwen 1.5, and we are now cooking Qwen2 as well, because we need to build good coding data for the pre-training. So this part, yeah, if you are interested in code LLM, you can try to use this. I think it is still the one of the best. I think it is the best 7B coding LLM. But if you have used larger models, DeepSeek Coder V2 is better. But later we'll have Qwen2, so you can expect that. We have a lot of friends, in the community. They are supporting us, helping us for people to use it. So you can, Hugging Face, we have our codes merged into Hugging Face. You can use it in Hugging Face directly, and you can use it with VLM for your deployment, and you can use Llama Factory and also Axolotl to train it. And if you are using Mac, you can use MLX, and for Llama Studio, you can use it there. And for the API now, it is supported by Together AI, Fireworks. Yeah, these are some of the things our connected with. So if you are interested in our stuff, you can check our GitHub, Hugging Face, and also ModelScope. If you are in mainland China, you can visit ModelScope. Yeah. So for the next part, I will introduce some more details about our training of the model. Yeah. So one thing you need to notice that most of the LLMs may be under-trained. So for the GPT-3 stuff, it is a very large model, a dense model, but it is only trained on 300 billion tokens. So for the chinchilla, people are talking about chinchilla law, but I think the success of Llama 1, 2, 3 demonstrated the significance of data scaling. And even if you scale it for small models, it actually works, even for things like 0.5 billion model. If you train it with multiple trillion tokens, it still works. But it is not increasing that fast. For a larger model, it will increases like things like faster. So previously, this is the sentence I used for Qwen 1, but for Qwen 1.5, I started to doubt about it. So model and data should be scaled equally. But I think for data, you can put it more. You can put it more on the data. But data quality is also very important, because it is very easy for you to collect a lot of data and you just put it into it. But if they are all if they are all trash data, it is actually meaningless. So you need to continuously scale up your data, but you need to find some rules to balance the quality and quantity. And you can even iterate your data for multiple epochs. We have tried for some times, but we don't often use this. It is actually helpful, but due to our resources, we for most of the time we only train for one epochs. Yeah. So what we have released, it is actually essentially a transformer-based language model. It is not something like today's RNN models, and we do not have some specific new task for the training. We just use the very plain training like next token prediction for the pre-training, and then using instruction tuning with like SFT, when you call it SFT, and we also use like DPO. We often use DPO. I just call it both instruction tuning. For the context length support, I just tell you that we can support it to 128,000 tokens. Because in our pre-training, we actually have trained it with 32,000 tokens. It is actually a bit hard to really pre-train it with such long context, but we actually have trained it with 32,000 tokens, and it can extrapolate to 128,000 tokens. We're now working on something like 200K tokens for the pre-training, and then we try to see that if it can extend it to 1 million tokens, that would be tremendous. But it runs really, really slow. And most of the models, we have 5 sizes. They have been trained with actually more than 7 trillion tokens, because there are too many trivial details. I cannot tell you really the exact numbers, because there are some iteration or things like that are very complex. But for most of the models, they are trained around like 7 trillion tokens. So it is much more than Qwen 1.5. Qwen 1.5 we only train with like 3 trillion tokens. So this is why we have so much improvements in this. And for Llama 3, I'm not that sure about that, because we are using different data, and I'm not sure if they iterate on their data, because based on Zach's talk, I guess they have done some multiple iterations. I'm not pretty sure about that, but we just use 7 trillion tokens. For the training data,
here, what would you say then explains the performance of Qwen models compared to Llama 3? Like, do you have any insights on the data? Have you done any pollution analysis of your data sets with respect to the benchmarks you're actually evaluating on? Like, what do you think is the main contribution or the main trick, so to speak, that made you outperform Llama 3 on those benchmarks?
For the base language model, because people are using different data sets, so it is actually a bit hard to directly compare the models, because there are a lot of models they are training with a lot more tokens, but they are even 10 points falling behind. So you can just put it that I think Meta may be doing some similar things with us. So I think the data quality might be something matter. But I will tell you what we have done for this. And for the pollution part, I think you are talking about data contamination. We are using like 13 grams to filter the test data. At least the test data we have, the testing we have done. We just filter the test data. We try to avoid the contamination. Contamination is actually quite meaningless. I can tell you something what we have done for the pre-training data, because it is a large-scale stuff. I cannot just explain it why we outperform and why we did not outperform, because I know there are a lot of people using even much more tokens, but they cannot achieve better performance, even far lagging behind. For what we have done, we just try to collect a lot of data from the public resources that we can get. We just try to get it. We try to make it cover a lot of domains. So actually, you have a large pool of data for you to get. So if you know about CC, Common Grow, there are a lot of data there. But actually, if you can find the goal there, it is not that easy for you to do. There are a lot of types of data, including plain text, codes, and mathematics stuff, but we pay special attention to code and math this time. This is what we have done. In comparison with Qwen 1.5, we have done something more for code and math. And for the next part, we're actually building the next version of Qwen, we pay more attention to codes and math. But for the plain text, yeah, most of the there are English and Chinese, and for English there are a lot of high quality data. But for Chinese, for a long time we actually filter a lot of data because yeah, you need to first guarantee the quality to it. But this time we have some new guys for multilingual, and they pay attention to some specific languages. So this makes the model, yeah, I think multilingual actually helps because you need to model the, this is our principle. We hope to model the human knowledge. Yeah, this is what we want to do. But we don't know what is the distribution of human knowledge. So we try to get more data and put it together. And we have a lot of sources, and we're trying to combine it together. How we judge it, because we have some evaluation stuff. So we just test it with the evaluation. For example, in our training, during like 1,000 steps, we just evaluate it, and next 1,000 steps, we just evaluate it on multiple data sets, and then we can see that if we can train it all right, and we can compare, yeah, different data combination experiments to see that which one is something better, because we do not really know what is the best data for a language model. We cannot just say, yeah, I think it is it, so just do it. We just based on the experiment. So we are actually doing some
across languages. Just how do you, what's the distribution of your data when it comes to Chinese, English, and other languages?
This is a bit secretive, but English is actually more than Chinese, and they take, I think it is over 80%, yeah, for both. And for the next part, we have some other stuff, multilingual part, and also some coding part. Yeah. We also do similar things that other guys do, like filtering. For filtering, we have some brutal methods, just like source filtering. For example, based on the URL, you just check the URL, and if it's often problematic, we will just dump it. Yeah. And for the deduplication, it is actually just simple, but we are doing cross-document deduplication. And for the next part, filtering, I think you need more experiments and experience for it. For example, how you write the rules to filter this stuff. You cannot write too many rules because there are a lot of good data. If you just throw it away, you actually do not have enough good data for good training data for you to train a good high quality model. You can also use model to filter it. For example, you just use the models to classify the data, or you just sample the data and just let it give some comments and just give it a score. We use the large model. Yeah, for example, our Qwen2 72B, and we often use our previous like Qwen 1.5 72B to classify the data. And for the next part, maybe previously people do not care too much about it, is how to make your model good at code and math. If you believe in that there is a good correlation between coding and math with the model's reasoning capability, I think it is quite natural to come up with this idea. I think people have discussed a lot about it. So you need to improve the coding and mathematic capability. And for the general things, things are not that difficult. Just you have a large pool of data. You need to figure out how to crawl out the mathematics related data and also coding related data, and use the same pipeline to filter the data and do it for iteration. It is just like a bootstrapping stuff. Yeah. So
a couple questions from the audience. First, did you use any synthetic data in the pre-training stage?
This is quite a good question. We are trying to build these things for it. I think for the mathematics part, we can use some, because we can use things like rejection sampling to build up some synthetic data for it. And we are now investigating how to improve the long context understanding capabilities, so we may do some synthetic data into it, but we do not do things very aggressively. We do not come to that part. I know maybe OpenAI and Google, they have done these things, but we do not do it quite aggressively. We just do it with mathematics and a little bit about code. Yeah.
Hey, quick question. So now that you want to add new features like expanding context length and stuff, how much do you focus on architecture changes versus data changes? It seems that data changes are much more impactful, and that project has already converged to a good architecture.
Yeah, if you talk about architecture, I can share the model architecture and about our ideas about like things like changes. And this is maybe a lesson for our team. I can share it to you. Before that, we have done some investment in model architecture building. At the beginning, we have done this research. I think Llama is not emerged yet. I'm not pretty sure about that, but we just follow our previous experience. We love to use the gate glue activation because we have some successful experience in multi-model training. So we use gate glue activation, and we think that the model training might not be stable, so we add another layer norm to it. There are some works just like norm former and magneto. So we have done these things, but finally we did not come up with a good model, just a mediocre model. And there are too many factors for us to discover, and for the model architecture it is very painful, but because you need to get back to it and just use it. So we have done some ablation studies and find that it is quite a good balance for the Llama architecture. I can share the details. For example, if you believe that the training it is actually unstable, but if you are using BF16 to train the model, it is actually, in most of the time, if your model are not too large, like over 100 billion parameters, for us, like over 100 and 200 billion parameters, it is a bit unstable, but most of the time it is really, really stable. So you actually do not need things like norm former or magneto. You just use prenorm, and things are solved. And for the activation, now Google, Gemma, it is actually using gate glue, but if you really check the implementation, you can use sweet glue, with good fused kernel to train it, and it is actually can be faster. So they have achieved a very similar performance with gate glue. So for the safest part, so we finally come up to a very similar Llama architecture, but we have some QKB bias because we have learned from a blog by the author of Rope to see that the QKB bias might be helpful for the long context understanding. So for this year, we are still keeping the QKB bias. And this is our story, but this tells us that you don't need to make drastic changes to your model architectures because it is really, really risky before you have built a good model with a good data. So you don't need to change it. And the improvements are quite trivial, actually. If you have changed it to totally another architecture, just like iron stuff, that is another story. But I don't think they are successful as like today's transformer architecture. Or Llama is quite successful because it is not only because of the model quality, but because it's open source, and then there are a lot of people using it, so people are based on it to do a lot of fantastic stuff. So if you do not follow this trend, you will miss a lot of stuff for example, it's not easy for you to adapt to like llama.cpp, and there are a lot of people that cannot use your model. Wow, that is a great loss. So I think we are really lucky to get back to a very similar architecture to llama.
Yeah, I think there is like the hardware lottery thing at play, and then there is now increasingly, as you said, a ton of frameworks like llama CPP. If you have something that's very similar to previous architectures, it's much easier to get adopted in the community. So that acts as an additional soft constraint on top of the hardware constraints, which is kind of fun. Maybe a question on the initialization side. Did you have any insights there? How do you initialize the weights? Do you use something like MIUP, or do you use just whatever is default in PyTorch, or like what's any insights there?
We don't use very strange initialization. We previously just used things like BERT initialization. I don't think it matters that much. Based on our previous experience, while things will come up to very similar performance and BERT initialization, I remember it is truncated normal. It is actually quite good. But if you use Xavier, I think it will be good as well. I don't think it matters that much. Yeah, that's a great question. And this is for the tokenizer and the model architecture part. But I can share something more about model architecture. And for the model architecture now, people are using MOE stuff. Yeah, like Mixtro, it is quite good, and DeepSeek MOE is quite good. We have done some investment in it, and we have done some research into it. So we have the MOE architecture, as you have seen, but I think MOE is another track, but based on the transformer, the base architecture, well, there's still some room, the like multi-latent attention, proposed by DeepSeek. It looks good. It looks good with the quality of multi-head attention, but much less KB cache. But for this part, what people are caring about is actually about the efficiency stuff, the memory footprint saving and faster decoding stuff. I think there's still some room in this part, but for a long time, maybe people are using the llama architecture for most of the time, because there are too many people are using llama. It is hard to change it to another stuff unless you are very successful, much more successful than this architecture. And this is what I think about architecture. I'm actually a little bit conservative in this part. And for the context stack extension, it is not that difficult, but you need to do it carefully. For example, you remember that previously people are just pretraining the model with 2,000 tokens, not just larger context. We have tried, for example, comparing with 2,000 and 8,000. 8,000 will achieve much worse performance. Significant worse at least. But for 4,000, it is surprisingly that it can achieve competitive performance with training with 2,000. So you can find that there are a lot of people actually train their model with 4,000 tokens context length, but you still need to extend the context length, right? You cannot just use it for 4,000. You cannot do anything. If you just use some things like NTK to extend it, it is actually not stable. You really need to train it. So we just start from 4,000 tokens, and then we continue to train with the same data distribution, but longer context, truncated to 32,000 tokens. We're now trying with 200 tokens, specifically 256,000 tokens. And if you have some methods to extend the context length, if you do not do anything, it sometimes can extend it to 2 to 3 times. It is very easy. You just need to use a larger base value. You remember the base values for the rope. Usually it is 10,000, but we actually use 1 million for it, and sometimes we use 5 million. So if you train it with like 1 million, and you can extend it to much longer context. Yeah, but we have some other stuff. Yarn is good. Yarn, you use static yarn. If you use dynamic, that would better. But it is simple to implement static yarn in like VLM. We have some collaboration with VLM. You can see that you can use static yarn with VLM in for Qwen. So you just use it. And we have a new technique. You can check this paper called dual trunk attention. We can even extend it for around like 8 times. So in our we are doing the experiments to extend it, for the context set. So it is actually not that hard to train a long context model if you have the architecture support. Training it directly just with full attention. If you are not using window attention, you can even train it with 256,000 tokens. Years before, I cannot imagine this. I think that it is too long, but now it is actually quite possible. There are still some room for this. We are investigating doing the experiments for the window attention. Sliding window attention. I think you first met it in Mistral, but it is a traditional method for long context. But if you directly use window attention, you cannot achieve very good performance. I recommend you to read the blog from Character AI written by Norm Shazier. It is really brilliant, and he has talked about a new way to combining window attention and full attention together. Actually, we have done similar things. So this is why you have found window attention and full attention in our Hugging Face code. Previously, we have found that if you have bottom layers for you are using window attention, and for the top layers you are using like full attention, that would be the best. But for others, they have some different conclusions. For the author of Rob, he would like to use full attention in the middle layers. For the middle 4 layers, for example, you have 32 layers, and in the middle for 4 layers, you are using full attention. That would be the best. And I remember that Norm Shazier doing something different. Just like one. Like 2 window, 1 full, 2 window, 1 full, and things like that. You can check in and do a lot of experiments. I do not have clear conclusion to it, but training directly with full attention is actually possible, and you can extend it with like yarn or dual trunk attention. You can see
on my side. How long? Like how many tokens do you use for the 32,000 continued pre-training? Like what's the ratio between the 4K and 32?
For 4K, it is almost most of the data, and for 32K, I do not really remember the number. Generally it is a few 100 billion. We usually do it for a few 100 billion, and you use 4K for multiple trillion, and you use 32K for 100 billion or 200 billion. Awesome. Just like that, but using this same distribution.
Some questions from the chat. Let me see which one I can pick up. Did you run any experiments to confirm the intuition about the model performing better in coding and math as a proxy for general reasoning?
This is quite a good question, because it is actually to evaluate the reasoning capability. This is something that are frustrating us, because you cannot say MMLU or even like GPQA. They are actually general reasoning stuff. We just used some human evaluation to test it. It actually improves, because the logical reasoning capability is actually improving. But there are still a lot of factors, because now we are just talking about pre-training. But when you finally come to use the model, you are using the instruction tuning model. So if you haven't done instruction tuning well, you will even ruin a good pre-trained model, possibly. So it is correlated, but not not that evidentially proved that, well, it is correlated with that kind of general reasoning stuff. Yeah, it is really hard to evaluate the reasoning capability. Yeah.
Thanks. And let me
okay,
just more from the chat, sorry, and then you can continue with the haystack slide. Let me see. Sure. Maybe some of these you can answer also offline in Discord. Let me just pick up one from Tayon. In optimization, how did you choose learning rate and scheduler? Did you consider mu parameter method to find good learning rate? I guess you just followed whatever Llama uses, I would assume, or?
It is a bit different from the others' experience. We are using cosine decay as well. Yeah, it is very traditional. Just using coming to the peak learning rate and then decay to the like 10% of the peak learning rate stuff. Yeah, using the cosine learning rate. But what we have done differently is that we try to improve, increase the learning rate as possible. Yeah, the peak learning rate as possible. For example, for the 1.5B model, I remember that it is around 3 to 4 E-3. It is really large for a small model, but for a larger model, we will decrease it to it. But even for 72 billion, it is that large. We are actually using 3 to 5 E-4. I remember that it is 3 -4. Yeah. So we try to use a very large one. If it is stable, yeah. If there is no unstable stuff happening there, you can usually test it at the beginning. And there's another work by Mini CPM. They have some different thoughts. They try to use constant learning rate most of the time, and then suddenly decay it to a very low one, and they think that is the best. We have tried it in small models, but did not find it really significantly outperform. And based on we do not have enough GPU, so we just try to be conservative. We are still using our previous experience. We just try to use larger learning rates as possible. Yeah.
Talking about GPUs, if you can share, like, what's your setup there? Like, how big is the cluster? What GPUs are you using?
No. Yeah, this is something I cannot talk. Yeah.
Sounds good.
Yeah.
No worries.
It doesn't matter. Yeah. Sure. Okay. Yeah. For the next part, then if you check the needle in the haystack, I think it is generally good for 72 billion instruct. And if you have know about like LEVAL, you can check the performance by yourself using OpenCompass. There was a work called OpenCompass. You can find it in GitHub, and they have a official website. You can run the toolkit to check the LEVAL, to run the performance like long bench LEVAL. Yeah, for 72B, I think it is good. For 7B, this is a bit surprising. It is really capable of doing in 128K, but I don't really believe that it is really capable of long context understanding. For me, long context understanding, you really need large models. You cannot expect really small models to do really long context, because long context, which means that complex context, you need to understand it. So you need to use a larger model to do it. I am very confident in our 72B for the long context, but for 7B, I think 64 is okay, but for 128, I'm not sure in real usages how it performs. And for the MOE model, it is a bit surprising that it is shorter than our expectation, because similar to the 72B, I think it can do at least around 128,000 in needle in the haystack, because needle in the haystack, it's not that difficult, but it can only achieve 64. It is a bit pity. So we just tell users that we can only support 64. You'd better not use larger than it. And for small models, we can just use 32K because we have really trained it with 32K, so it can support it. Yeah, this is about the context length support. And if you check the model performance, if you check our blog, I think you have noticed the figure here. We have very good performance in the benchmarks. We have tested a lot of benchmarks. For example, MLU, and for MLU Pro, this is a new one. MLU Pro just came out very recently, and you can find that it is improving quite a lot. And for coding part, we are quite confident in it, and also for the math part, because we have invested quite a lot coding and mathematical data in the training stage. And for the multilingual part, and we have classified it into some domains, and we have reported exam and understanding, and we are actually doing experiments on 12 languages, and including the familiar Western European languages and some Eastern Asian languages like Japanese and Korean or these stuff. Yeah, Qwen2 70 to be better than especially the larger model Qwen 1.5 100 and 110 billion. And for some data sets in the training part, it is better than Llama 3 70 billion. So we are very confident in our pre-trained model as well. Yeah. There are some detailed scores in there. We are still writing the technical report. I think people are asking about this. We are still doing on it. I'm not sure this week, or I think it is next week, we will release the technical report, so we will know more detailed scores about it. Yeah, and for the small models, we're still performing quite good. Yeah. And this is for the base language model for the pre-training part. And for the next part, I will introduce more about like instruction tuning. And for instruction tuning, for SFT, I think there are some different opinions about how to build your SFT data. Previously, people are thinking that you can even use 1,000 data to build a SFT. This is quite amazing. Yeah. By Pengfei, they just built 1,000 samples, and you carefully curate it, and you can train a good model. But for the comparison, you just compare with Alpaca. I think it is not quite a strong model. And today you have Llama 3. Llama 3's instruction tuning is really, really good. I think this may make our models sometimes that you use. Yeah, sometimes you will find that, wow, Llama 3 is still better than Qwen2 in my cases and for some users. So we have heard a lot of noise, and some people say that, wow, Qwen2 is great, Qwen2 is the best, and some people will say that, well, Llama 3 is better than Qwen2. I think the gap may be in the instruction tuning. But for our understanding, we try to increase the diversity as possible, because if you just increase the amount, this is actually quite meaningless. And previously we have a word called instack. We just try to see that how diverse our data, and also how complex is the prompt, because not only you need to increase the whole diversity of the data set, you need to improve the quality, which means that your prompt should be something a bit complex and difficult for a model to answer. If you just have very simple questions, this is actually quite meaningless. So we just put tags into it, just automatically let the large language model to put tags into it. If the prompt has more tags, which means that it is more complex, so it might be a good one. But finally, you need to use human quality control. You need to have a lot of human annotators to do a lot of complex stuff. So for SFT, it is a data engineering where you just need to invest your efforts into it. But people might expect something more interesting than SFT, because there are a lot of people doing SFT in the community. I have a lot of friends fine-tuning Qwen, like Dolphin. They are building very good models. They have their own SFT data sets. But today, people would like to see that, yeah, I can build a model similar to ChatGPT, but can I really be competitive to ChatGPT? I think many models surpass GPT 3.5, but people are just expecting that if we can really approach GPT-4. I think Qwen2 is still lagging behind in some difficult queries for the model to answer. But for more often used cases, I think Qwen2 is generally okay. And we have done some investments in the IOHF part. Last year, we have done a lot in traditional IOHF. You remember PPO. There are a lot of people just bragging that I have done some PPO stuff, but they cannot throw out a new model to the community. I think not many people have successful experience in this, except for some big corps. They have GPUs, they have good architecture to support you to train PPO model, because it is really, really hard. You need to train simultaneously, like 4 models to simultaneously, and you need to have very good high quality reward model. And today in the open source community, we only have really high quality reward model by NVIDIA, the Nemotron, the reward model. It is really, really large, but previously we did not have good reward model. And we put more efforts in DPO. I love DPO. The reason why I love DPO is that it is quite simple. Yeah, it is quite simple. You just do it just like SFT. This makes you can put your efforts into your data. So everything is about data. Yeah, you just put your efforts into data. You have pair data, and you can ask the human annotators to see that whether it is good or not. And you have some label data. You can train the model to classify the good quality and low quality pair data for DPO. You can do these things. Yeah, so you put more efforts into the data, you will have better models. So we continuously do these things. So
sorry for interrupting. Just FYI, we have maybe 3-4 more minutes. I'm not sure how many slides you've got, but just FYI.
I can accelerate. Yeah. And another part is that for the model merging part, I can use it in one sentence. Model merging is quite good. We usually merge SFT and DPO model and share it to the community, because for the DPO model, it is not that good in some tasks, just like for some agent stuff, some rack stuff. So we just combine it together. And we have a word called online merging. You can check it online. We have a paper called online merging, and online merging is actually helpful. And for the results part, I do not need to share too much. People today would love to compare the models for the data sets for pre-trained model, but use it for instruction tuning model. I don't know why, but we also do it. It performs generally well. For the 7B model, it is performing even better than very recently released GRM4 9B, and including a line bench, empty bench, and also some MLU stuff. Yeah. And for the coding and math, and you can find that the Qwen2 72B, if you really use it, you will find that it is much better than Qwen 1.5 if you are the users of Qwen 1.5, and it can be used in multiple languages. And this time we have done something more for the safety part. I have a friend from a company. They are doing something for safety evaluation, and they also tested our model, and they tell us that, well, your model is quite safe. I didn't do too much work on it, but the model performs generally well. For some illegal activity, fraud, and pornography, it generally performs well in comparison with some other models. Yeah. So finally, a very quick summary. If you have any more questions, just shoot me. Yeah, we have a base model, I'm very confident in that. I have Qwen2 instruct model. It is generally okay, but we will do something better instruction tuning, and maybe we can share the next version of Qwen2, just updating the model checkpoints. It performs well in the benchmark evaluation thanks to our large quantity of data, and it will be a good starting point for people to fine-tune or integrate with your applications. So I encourage many of my friends to use my model to fine-tune it, to build your own model, just like Dolphin. And my friends in Vietnam, they are building some Vietnamese models, and we have some friends in sea area, they are building southeastern languages. They can be integrated into multiple modalities. If I have a chance, maybe later we will release some new models integrating vision and audio, so you will see something like competitive to GPT-4V in the open source community. I hope you will like it. And we need to continually scale up. And this is still it is a game of scaling up the model and also the data size. I think there is still much room, at least in my experience, there is still much room for at least Qwen2 to improve. I hope at the end of the year we can really be competitive with GPT-4. And final some discussions, I think people may be expecting better alignment techniques. Not just data, but you need some good techniques to make it more stable. For example, you hope to use online learning, but online learning is actually quite difficult for you to use. And you can fine-tune it in different domains to get its potential for other usages. I hope you like the Qwen2 models. I think I will later release some more videos about how to use Qwen2 in YouTube. So stay tuned. Any questions, just shoot me if we have time.
Perfect. Junyang, thanks a ton for the talk. This was really interesting. Talking about new stuff, there is a question in chat. How do you decide when to stop training Qwen2 and start training Qwen3?
This is actually a good question. So it is about the next version. We are actually building a new data for our version. It is about the training data much. Because you can use the same recipe for the old models for instruction tuning as well, but for training, it is a high cost work. So we need to make the decision very carefully. So for Qwen3, I think the next version will be Qwen 2.5. We do not want to make things too aggressive, because people may think that Qwen3 will be much better than Qwen2, and if this is not, people may be disappointed. I think it will be Qwen 2.5. It is mostly about pre-training data.
Perfect. And one more question from Baba. Any roadmap for African languages?
African languages, we are working on it. We are working on it, but it is a bit hard for us to collect the data. Not as easy, just like Southeastern, because we have some ways to know about how to collect the data. But African data, it is actually not that much in the whole world or in the web. You can crawl it. It is a bit hard.
Awesome. Junyang, thanks a ton again. I'm going to stop recording